Okay, so we are going to do something called Eulerization. If we don't have an Euler circuit, we're going to duplicate some edges so that we have an Euler circuit. So let's notice this graph. Remember, to have an Euler circuit from our last video, we have to have every vertex has to be even. And we have quite a few odd ones here. So let's notice this one's even, but 1, 2, 3, this is an odd vertice. Here's another odd vertex right here. Here's an odd vertex here. Here's an odd vertex. And here's two odd vertices right here. All right, so what we want to do is make those odd vertices even. And to do that, we duplicate edges. And we end up with even vertices, and then we can find an Euler circuit. So, if we've got a postmaster walking down the street, it might be that she has to walk a street twice in order to get to all of the locations, just because there's not an Euler circuit. All right, so we're going to make an Euler circuit out of these situations. So let's first note that right here we've got two that have three edges coming out of them, two odd vertices. So what we will do is we will duplicate. Well, I thought I had it on draw. There we go. We will duplicate this edge right here. And now notice that we have 1, 2, 3, 4 edges coming out of this one, and 1, 2, 3, 4 edges coming out of this one. So they're both even vertices. Let's do the same thing over on this side. And now we've made them even vertices. Okay, now we still have these two guys to deal with. This one has 3. This one has 3. And notice they're not next to each other like these two were. So when that happens, we want to duplicate every single edge that's in between them. So I'm just going to duplicate this edge, duplicate this edge, and finally duplicate this edge. Now notice that I now have 1, 2, 3, 4 for this. It's now even. 1, 2, 3, 4, 5, 6. So this is still even. 1, 2, 3, 4, 5, 6, still even. And then 1, 2, 3, 4, it's now even. So all of my odd vertices are now even. We've Eulerized this graph. And now that we've Eulerized it, let's find an Euler circuit. So I'm going to change my pen color so that we can distinguish it from the edges that I've added. And so that we can write out our circuit, let's call each of the vertices by a name. G, call this H. Okay, so I'll begin up here at A, and I'll go A to B, and I'll cover, and I'm kind of missing the line, but realize that I'm meaning to cover the edge. So let's see, A, B, and then let's just go to C, and then we'll go to F, and then let's go to E, and then I'll take the red edge first and go to B, and then I'll take the black edge back to E, and then let's see, let's go red edge to H, and let's go over here to I, and then I'll take the black edge first to F, and take the red edge back to I, and then I'll go down to L, and over to K, and then I'll take the red edge up to H, and I will come back on the black edge to K, Then let's take this edge to J, and I'll just continue this down here, and up to G. And then let's see, let's go over to H, and then up the black edge to E, and over to D, and then I'll go down the black edge to G, and back up the red edge to D, and then finally finish the circuit and going to A. And there are more than one answers to this, so realize there are multiple ways that we could Eulerize this graph. That's just one of the sequences, or one circuit. Okay, so let's do one more. Let's Eulerize this graph, and then we'll find an Euler circuit. So let's look for the odd vertices. So let's see, there's an odd vertex right here. There's an odd one right here. There's an odd one here. Got an odd one there, and an odd one there, and here, and here, and here. Okay, so multiple odd vertices. So let's begin. These two are right next to each other. Let's just go ahead and duplicate that edge to make those 4 and 4 coming out. These two are side by side, so I'll just duplicate that edge, making that a 4 coming out and a 4 coming out there. And then let's see, I still have this one and this one. So let's just go ahead and duplicate that edge. So now there's 4 coming out of that and 4 coming out of this one. And then let's see, I still have this one and this one down here. So there's not just, they're not side by side. So I have to just go across the pathway and double. So let's go here and here. So now this has 4. This one that was even still is even. It's got 6 coming out of it. And now this has 4. And we have Eulerized the graph. All right, now I'll change the pen in order to find an Euler circuit. And let's go ahead and label these just so that we can tell what our circuit is. I know my B doesn't look very much like a B. Okay, so let's just start with A again. It doesn't really matter. So I'm going to start with A and go to B. And then I will go to C. And let's go to D. And I'll go down to H. And let's see. Let's go to L along the blue edge. And then we'll go to P. And I'm just going to go all around the bottom now. So let's see. Let's go to O. N. I'll go up a blue edge to J, back down the black edge to N again, over to M. Oh, that's not very good. Up to I. Over to J again. All right, let's see. Let's go across to K. over to L, up the black edge to H, over to G, and I missed, but you know it's supposed to be on that edge. And let's go down the black edge to K, and up the blue edge back to G, and then up to C. And I'll now take the blue edge over to B. I'll go down to F. And I'll go ahead and travel both of the edges going down to J. So blue edge to J, back up to F. And then over to E. And up to A. And I have now completed my Euler circuit. It has covered every single edge.